What's up everyone, JayzTwoCents here. We're going to talk about Corsair's new AIO cooler, the H150i Pro RGB. We saw this briefly at CES. They had it in some systems there. We didn't really get very hands-on with it. I've actually had this for a couple of weeks now. I'm just now getting around to it, but I saved you guys the pain of watching me unbox it at least. At least it's already over here, put together. So we'll talk about what's different, what makes it pro, and we'll see how well it performs.
The new DG7 series cases from EVGA offer PC enthusiasts more of what they love, like tempered glass side panels, vertical GPU mount, integrated RGB control board, DG tuner, and an awesome 3-year warranty. To learn more about the DG7 series of cases from EVGA, head to the link in the description below.
So it's a pretty basic run-of-the-mill AIO. You've got your Asetek pump right here with its copper base plate, much smaller pump design though, like overall it's very tiny. You've got your flexible tubing here with its paracord sleeve, which looks really nice. Triple fan design, so it's a 360mm radiator. It looks like it's about a 25mm thick rad, so it's definitely a slim rad, making it fit in many more applications. The fan is probably what's most different though with this series of AIO versus the older H series. These are maglev bearing fans. So not sleeve bearing, fluid bearing, ball bearing, they are a maglev bearing. So it's actually riding on a field of magnetism, making them super cool. And as you can see, you can see that. They actually spin very, very easily, but they are static pressure optimized, perfect for radiators. Of course, they are PWM wired, so you can plug them into your motherboard if you want. Unfortunately, the cable that comes off the pump to plug into the fans is not detachable, unlike the older H series coolers. So if you decide not to use the wires coming off the pump and you want to control it through your motherboard or something, then this is still going to be plugged into the pump, unfortunately. This plug coming off the pump right here appears to be power and RPM circuit, and then we have our SATA power. None of this is detachable. The only thing that's actually detachable is the USB cable that comes with it, because this is how you connect it to Corsair Link to control things like pump speed, RGB color, fan speed, and all of that. Unfortunately, you have all these wires coming off the pump. It takes what's otherwise a pretty basic and clean design and really clutters it up with all these wires, but that's subjective, I guess. One thing I want to point out though is a lot of people tend to freak out at the idea of aluminum radiators. Let me show you this right here. This is a copper base found in pretty much all AIO coolers with an aluminum rad. So there's that. But anyway, these are maintenance free. They're not designed to be opened up and touched or played with or drained in any way whatsoever. So in a nutshell, that is that. Now let's talk about brackets and compatibility here, because unfortunately, this does not support Threadripper out of the box, which I think is extremely disappointing considering the fact that this cooler launched a good 5 months or so after Threadripper. They had plenty of time to design a bracket, because these are just brackets that connect to the bottom of the pump very, very easily. You just slide them up, line them up, and then lock it into place. That's it. So if you want to switch it over to the AMD bracket, it is extremely easy. So all they had to do was come up with a bracket design for Threadripper. Now they say that they're going to be incorporating a bracket in the future, and I believe you can send away for a bracket when it's ready if you're an existing owner. I just still think they had plenty of time to get that ready, but that's just me. So that means it's going to support all of your 11 series sockets, 13 series, 2011, 2066, AM2, 3, 4, FM sockets, all that stuff. So it's basically got backwards compatibility all the way back to like the last 10 years, starting from Ryzen down. So it does support Ryzen though. So the way they decided to support AMD is by having this bracket, which uses the factory clip locations. If you guys have ever installed an AMD cooler, you know it's got 2 spring-loaded clips. So instead of coming up with a pass-through backplate like they did from mainstream Intel, they maintain the clips, and then you have got somewhere in here, you've got this bag of, I'm not gonna take them out, but you see you got this bag of extra screws and clips. That way it just snaps down onto the AMD cooler, making it kind of a one-piece solution to fit all AMD sockets instead of, well, minus TR4, instead of having to have that slightly different offset like it has for Ryzen. Okay, that's enough of that. Let's go ahead and install this beast and let's see what it's capable of. So this is Corsair Link, and you can see we have a lot of information here on the screen. We've got our motherboard temperatures, all the temperature probes that are available to Corsair Link will show here. Of course, we've got our fan speeds, pump speed, all the information you could possibly want is here in its own graph. On the left right here, you can see this is everything that's represented on the right. So we can set warnings for different temperature settings on the motherboard. So we can set motherboard warning temps, CPU warning temps. We got multiple profiles here. I've got it set to balanced right now, which is a pretty quiet mode. These fans right here are a 400 to 1600 RPM maglev fan. So when we set it to max, which is performance, they're speeding up slowly. It's got a very smooth curve, but you can see everything just kind of reset right here according to the RGB. It was all set to white. But each profile has its own color settings as well. Now obviously I've got the radiator set out in the open like this. It's not in a case because I want to see what the absolute cooling capability of the unit itself is. So obviously your results may vary based on what you're about to see depending on the kind of case that you have it in. But by having it in the open air just like this, and now it's really starting to blow, means that we are only limiting the cooler by the cooler's own ability to cool, if that makes sense. So this isn't like a whole in-depth on how to use Corsair Link. This just has all kinds of options and stuff here, the profiles. And I'm gonna set this to balanced for right now in this particular test because that's the way it shipped out of the box. And I wanna see how it performs if we just plug it in as is to see how well it actually performs.
Transition.
Okay, so funny thing, I was actually running Prime 95, the latest version. I think it dropped 1.5/2018, so brand new version with my 8700K. Was running 4.7 all-core overclock at 1.323 volts, I think it was. About 20 minutes in, the system just shut down. It didn't trip a breaker or anything. It powered right back on. But I attribute that to possibly overheating VRM because we are in an open air test bench. And the VRMs were almost too hot to touch. The heat sinks were. So now I have this fan blowing down on them just to be safe. But if we look here at AIO now, you can see it's pretty damn consistent. We didn't really see a rise over time. This has been running for 22 minutes. So we've got about 45 minutes of stress testing that has gone on this so far. So like I said, I skipped the stock clocks. I went straight to the 4.7 overclock on all cores. And if we take a look at the statistics, you can see these are the temps we're running right now. Cores are sitting in the 70s and 80s. These are the maximum temperatures ever achieved. So we're looking at upper 80s and the highest. And those are the peaks. If we look at this right here, these are these high peaks where it jumps up momentarily. And yeah, so if we look at our averages though, looking pretty damn good. The average on the package was 68.5 and down into the mid to low 70s. Now these temps and things are actually not that bad considering the fact that we were set to the balanced mode. All right, not even on performance. In balanced mode, it was the RPMs on the fan were sitting, you can see right here, look at that, 660 RPM, 714 RPM. So this is kind of the worst case scenario. If we move this to performance mode, then the fans definitely start to ramp up. You'll see the lights turn off. This is loading a new profile. The pump is just changed, so the pump speeds up. And this speeds up based on temperatures. But if we go back over here to Corsair and we look at the fluid temp, you can see the fluid temp, even under this load, is 29.2 C. And we are still running right now on AIO. So yeah, that's actually not too bad. Yeah, I know it's a trial version, support your devs. My key expired. I know I'm a bad guy. But anyway, it's incredibly flat. So what you can see is we kind of met our max temperatures in like the first, 90 seconds. And then, as you can see, it maintained very, very good temperatures. So what about gaming though? Let me go ahead and stop this. What I want to show you too is how fast the temperatures will drop back down once we stop the test. So yeah, it's incredibly fast. I mean, look, we're already back down to the 30s right here in our cores. One core sitting at 52. It's because it's still running something on that particular core. This one will drop back down eventually. I kind of noticed this with the 8700K. Core 3 just likes to stay really warm when things are sort of running. But anyway, you can see with Corsair Link, check this out, back into the 30s very, very quickly. The package is down to 52 and dropping quickly. And look at the fluid temp. Look how fast this starts to drop. See how it's just dropping kind of a tenth of a C about every second and a half? Not bad. Not bad for an AIO. And then with Heaven Benchmark running, you can see our temperatures don't really move very much at all. You might notice one core sort of bounce around. Same thing kind of happens with games where the CPU is not under a huge load In gaming, you can see our GPU, obviously, temperatures are going up because the GPU is obviously being stressed in this particular test. So all in all, I mean, the cooler is definitely doing its job. If it can keep an 8700K that's overclocked to 4.7 on all cores, running about 1.3 volts cool under the lowest, not lowest necessarily, but 650-ish RPM fan speed, pump at its lowest speed, where noise was sort of the bias rather than cooling performance. It managed to stay about 20C underneath our TJ Max or our thermal junction max on the CPU, then I think it's definitely doing a great job. The ML bearing fans are nice and quiet. As expected, I've used ML fans on quite a few things. Anyway, there it is. Your results may vary. Keep in mind, open air test bench as well as a aftermarket thermal paste installed. So you might see a couple of C increase depending on your case airflow. So that's something to keep in mind. But when you take into account just the cooler and what it's capable of doing in this open air environment, I think Corsair has done a good job at providing a CPU cooler that can keep all CPUs with the exception of Threadripper cool until that bracket comes out. So there you go, guys, the H150i Pro RGB from Corsair. Links on where to buy is down in the description below. And if you guys have any other coolers you think I should check out, make sure you comment down below on what we should get and we'll test it. Anyway, we're gonna go, guys. Thanks for watching. And as always, we'll see you in the next one.